Welcome everybody to this new session of the Network of Resources webinar series. I'm Federico Rondoni on behalf of the Network of Resources, that is an European Space Agency initiative that has the aim to bring users to cloud platforms and cloud services to analyze and use Earth observation data. The Network of Resources webinar series is a series of different sessions that show how the different services and providers available through the NOR portfolio can be used to work within the cloud environment. Today we are here with William that will show us the Sentinel Hub platform and all the different services that are available through this platform. And I want to remind all the participants that while we are going on with the presentation, there is a possibility to write any questions that you may have inside the chat. We will address them at the end of the presentation from William. There will be a question and answer session, and at the end of the question and answer session, there will be also a presentation of the Network of Resources portal and the Network of Resources founding scheme. So I want also to remind every participant that the session is recorded and that will be later available through the Network of Resources portal and on YouTube. Without please, William.
Okay, thank you very much, Federico. I'll just share my screen with everyone. Okay, cool. Today happy to introduce you to the Sentinel Hub APIs that are available through the Network of Resources. So my name is William Ray, and I'm a remote sensing engineer here at Sentinel Hub. And today I will give a recap of the APIs that are available to you, and then introduce our kind of core synchronous APIs, so catalog API, processing API, and statistical API. I'll then show you how you can get started with those APIs. Firstly, showing off the request builder application that is available to Sentinel Hub users, as well as running through a Jupyter Notebook demo showing the APIs in action. And then to conclude, I'll go into a bit more detail about some of our APIs that you can use to scale up your workflows. And then we'll end with a quick summary and some time for some questions. So to kind of give us some context, why the Sentinel Hub APIs were kind of thought up was that we really wanted to make solving the world's problems with satellite imagery easier for EO experts, but also less expert users. So a big thing for us is that if you can see it from space, you can also monitor it. And these applications can be wide-ranging, from monitoring forest fires to flood events, deforestation, and a lot of this can be powered through the Copernicus program, as well as commercial satellites, which offer resolutions up to 30 centimeters. A big theme of all these applications is that they cover large areas, but also large timescales, and having an API-based workflow makes this far more manageable than running this workflow locally, because you can very easily scale up with cloud computing technologies. However, going back a few years back, accessing and using satellite imagery was quite a difficult process for a lot of people, including myself when I first started in the industry. There's lots of different various file types you need to deal with. You have to think about metadata, your image projections. A lot of the data is not optimized for cloud processing. And you're dealing with huge amounts of data. So like a Sentinel-2 tile, that's a gigabyte of data straight away. If you wanted to run a time series analysis on 20 different timestamps, you're looking at 20 gigabytes of data straight away. And this all kind of created a very chaotic, tedious, costly work for a lot of people. It meant like developing algorithms was slow. The learning curve was really difficult. So the team at Sentinel Hub thought, well, we can make satellite imagery far more accessible to the masses. And we've achieved that. So we can make satellite data, whether that's the Sentinel missions, Landsats, commercial providers. We've made it easily accessible for all these data sets to be browsed and analyzed through common APIs, either delivering the data to your local environment or streaming to a web application. So we've made it far easier to quickly access the imagery without having to worry about how to store the data, how to process it. You don't need to worry about stacking bands, metadata, clipping the imagery. That's all kind of done in the back end of Sentinel Hub. And what you get at the end, we'll see here in a couple of slides' time actually, you get the data that you need. You don't get all the byproducts that maybe aren't needed. So the data sets that we offer the open imagery from Copernicus and USGS. So that's the full Sentinel-2, Sentinel-1, Sentinel-3 archives. We also offer the Landsat archive as well, so going back to the 1970s even, as well as a variety of commercial imagery as well. You can even import your own data into the platform. So this could be aerial imagery, it could be additional raster data that could aid your analysis. And as well, we also offer several Copernicus data sets. So things like Carine land cover, the Copernicus DEM data, and other associated Copernicus mission data. And you can access this through API. This could be through a variety of programming languages, so JavaScript, Python, R. As long as you can run a curl request, you're usually good. And this can either be delivered to your local machine, but you could also stream the data through OGC compliant APIs, so things like WMS, WMTS, WFS layers, and you can use this to power web and mobile apps, as well as GIS, cloud, but also desktop applications. So for example, Sentinel Hub has a dedicated QGIS plugin that you can use to stream the data into your application. So to give a very high overview of our APIs that are available, as I have just talked about, we have OGC API, which allows you to stream satellite data effortlessly into your GIS application using the OGC compliant APIs, so things like WMS. We have Process API, our most commonly used API to access the raw satellite data, as well as rendered imagery, so visualizations, but also analysis as well. We have Batch Processing API, which allows you to request larger areas and also larger timescales. We have Catalog API that enables you to search the open data catalogs. We have Bring Your Own Data, where you can bring your own data in, as long as it's raster data and meets the requirements of our cloud-optimized GeoTIFF format, you should be good. We then have third-party data imports, where you can purchase and order commercial data into Sentinel Hub. We have Statistical API, where you can calculate statistics bypassing the pixels completely. This enables you to very quickly create time series analyses. And we also offer a batch version of this as well. So you can calculate statistics for up to thousands of polygons at a time. And then lastly, our newest API is the Asynchronous Process API. And this acts as a bridge between process and batch processing API. So this data is delivered asynchronously, but is a little bit easier to implement than batch processing API. So I'm going to go into detail with three of our APIs, so Catalog, Process, and Stat API. Firstly, Catalog. This is an API that implements the stack specification describing the geospatial information about the different data sets that you can access through Sentinel Hub. So this includes our open data sets such as the Sentinel missions. And this allows you to search all data collections for the data in your area of interest and specified time period. And so you can see on the right here, we have an example. We're looking for an area of interest over Rome. You can return back the full Sentinel-2 tile geometry. You can see which Sentinel-2 platform it was collected by, as well as things like cloud cover percentage and the projection of the imagery as well. Secondly, we have Process API, which is the most commonly used on the platform, which this is how you can access the imagery directly. So which is a little bit different with Sentinel Hub is that while data has been distributed in tiles in the past, so if I go back to this slide here, you can see the ID of each tile. We want to actually hide this complexity, and actually we want to just make data available to you through a very simple means of giving the API a area of interest and a time period. And you do this through an API request where you can specify these things in your payload. Here we have a bounding box and a time range. We also have an eval script defining our inputs and outputs. So here we're inputting 3 of the Sentinel-2 bands and then outputting them as a false color composite. The really neat thing about Sentinel Hub is that you don't have to download the full Sentinel-2 tile. And using this payload and eval script, what we're doing is only returning the pixels we need. So we're only returning the pixels in the time period that we requested, only for the area of interest we're interested in, and also only the bands we're interested in as well. So we're only outputting 3 bands here. We don't need the additional bands that are available through Sentinel-2 if we don't need them. Of course, there's still the option, if you want to download all the bands at the same time, you can still do this. So next we have Statistical API. So this enables you to bypass the pixels completely and calculate statistics based on the imagery itself. So, but at the same time, not having to download the images. So you can, again, specify an area of interest, a time period, an eval script, and some statistical measures that you want to calculate. And based on those parameters, you then return the data in a JSON format and can then quickly derive time series data, for instance, or histograms. So let's have a look at a more traditional workflow. So you'd have to download your image. You'd then have to calculate NDVI, for instance. You'd then focus on a field of interest. You'd then probably have to clip the imagery or use Polygon, to which then you can calculate the statistics from that field. So with Stat API, you actually eliminate these 3 steps of actually downloading, processing the imagery, and you can get straight to the actual analytics that you need. And this is a screenshot from EO Browser, our kind of graphical user interface application. And you can see here Stat API in action, where you can quickly draw out a field and derive time series data from this field. Okay, so that I wanted to be quite brief there to describe our general offering, but now I want to go into a couple of demos just to quickly show you what the APIs are capable of. So firstly, I'm going to show you Request Builder. This is an application that we developed at Synergize to actually reduce the learning curve of running API requests in Sentinel Hub. And it's super easy to use. So after you've logged in, you're here at the Process API screen. We have several parameters we can change. So I'm going to pick a new area of interest so we can zoom in somewhere else in Italy, for instance. Let's go to Florence. I can click here on the bounding box button, create a bounding box. I can change my time range really easily. We have Sentinel-2 acquisitions actually highlighted here, which is really cool. I'll leave that for now. And then actually, if we scroll down further, we can start to see what our requests actually look like. So we have an eval script here. This is super easy. We're just actually inputting the blue, green, and red bands, and then returning back those bands. We're multiplying them by 2.5 just to make our image look a little bit brighter, but we could remove those if we wanted. And then we see how this looks actually in a curl request. So you can see here we have our bounding box, our time range, the data collection that we're using, and then our eval script is down here as a string. We can then quickly send this out. So I'm going to click send up here. And look, we return back an image. So this is currently the most recent image in the time range that we selected, but we can very quickly add a parameter to adjust this. So go to options. I'm going to go to mosaicing order. And I'm going to select least CC for least cloud cover. And actually, if we go back to our request now, you can see this has actually been added to our request automatically. And if I now send this request again, we return back the least cloudy image in our time range. So that shows how super easy it is to adjust your API requests and save you time searching through the catalog for cloud-free imagery. It's something that your API request can do automatically. You could then quickly also change the inputs and outputs. I'm going to change band 2 to band 8, for instance, and then just change around the bands which we're returning. So band 3, 4, and 8, I think. And you can then press send. And okay, actually, I've got this the wrong way around for a false color composite. Let's just quickly change this again. And send this off. And what we return here is the false color composite. So the red pixels here are actually vegetated areas, and then the darker pixels here is the actual city of Florence. So in addition to that, you can also change the language. So we had a curl request here originally. We could change this to Sentinel Hub Python package, or JavaScript. We have the Python requests library as well. All these you can quickly translate, and then you can copy and paste into either your Jupyter notebook or the command line, for instance. So that kind of concludes what I wanted to show on Request Builder. I'm now going to switch tabs over to a Jupyter notebook I've got ready to go for you. In this notebook, I've got some examples for Catalog API, Process API, and then Statistical API. The first thing we want to do is import some libraries. So I have some common Python data science libraries such as pandas and matplotlib to import, as well as our dedicated Sentinel Hub library here. So I will run this cell. And then the first thing we need to do actually is to pass our Sentinel Hub credentials to our config file. So I already have a profile set up where I have my client ID and client secret ready to go. And I can run this cell here to implement that. And then we can start looking into actually setting up an area of interest. So here I have an area of interest in South Austria. I will just run these cells here to view this. Okay, it's not working correctly, it's fine. We'll see the area of interest in a sec once we run the Process API request. The first thing we can try out, though, is to actually search and discover data. So I'm going to initialize the Sentinel Hub catalog class here, and then we can actually build a request. So I'm using our bounding box we defined here, and the time interval from 2022. I then have a data collection for Sentinel-2, level 2A data. And that's all I need to add. I have an area of interest, a time period, and a data collection. So if I run this cell, I then return back my results for the time period. So we can see we have 8 results. And then you can use that information to maybe tailor your process API requests. However, it's not like an essential part, especially if you're using open data sets. Like if you're looking in a time period of 1 month, you're very likely to have Sentinel-2 imagery in that time because of the 5-day revisit time, for instance. So Catalog API is great for discovering data, but it's not an essential step. So next, we're going to show you Process API. We already actually ran Process API request in the Request Builder app, but I'll show you how we can set this up in Jupyter Notebooks. So the information that we need to specify is an eval script, our data collection. We have a time interval in there as well, the format of our response, the bounding box, which we've already defined, and optionally, you can also include a mosaicing order. So as you'll see in this example, we're going to add a least cloudy acquisition, and I'll show you how you can do that. So again, we're just making a true color image, so a really simple eval script here. And we're setting our data collection as the Sentinel-2 level 2A, and a time interval from the 1st of May to the 20th of May. And it's as simple as that. So I'm going to run this cell and the ones after. I just have a little function to plot the image afterwards. And we can see here we're returning back our area of interest for the time period. If we wanted to add the least CC or the least cloudy, we could add that in here. We would add like an additional argument, and an even quicker way of doing it actually is going back to Request Builder. And if I change my Python library to shpy, I can scroll down. I can see that it's in other arguments, and I can actually just copy and paste this line into my request. So let's just do that really quickly, like so. Just sort out my indents, and then you could run, okay. I will remove that for now. Okay, I've broken that somehow. Bear with me, sorry, this is the perils of a live demo. I will copy and paste the full part. Okay, I will not worry about that. We'll get back to that. So, sorry about that. To carry on, you can also actually tailor your visualizations as well. So for instance, in the second example, I'm going to show you how you can calculate NDVI and then visualize this in an eval script. So we have a different eval script here. We have different bands being inputted. So we have band 4 and band 8. So the red and the near infrared, as well as a data mask. And our output is 4 bands. You can then see here in the video evaluate pixel function that we're calculating NDVI. So we're using the NDVI formula. So the near infrared minus the red divided by the 2 bands added together. And then after that, we're actually using the result of that to calculate an array named image vowels. And with this, we're actually using various shades of green to visualize the intensity of the vegetation. So I will run this cell. We have the same parameters as previously, so we're still using Sentinel-2, have the same time period, and we've got the least CC actually already defined in here. And I'll just run this cell. And we can see here's our NDVI visualization. So we could really quickly change the time period. If I go for November, it'll probably be slightly less green. You can start to see it's slightly different later in the year, for instance. But you can play around with the visualization as much as you want. And actually, there are several eval scripts that are available. So if we visit the custom scripts repository here, you can actually access several Sentinel-2 visualizations. So if you wanted, let's find a good example. Let's go for the shortwave infrared one here. You can actually copy and paste an eval script like so and input it into your eval scripts here. I'll then run the cells again. And we return back a shortwave infrared visualization. As simple as that. As you'll notice, the resolution is slightly degraded. That's just due to shortwave infrared band being 60 meters resolution rather than the 10 meters resolution of the true color or the true color and the near infrared bands. Lastly, I want to show you a statistical API. So this is where we bypass the pixels completely and just access the statistical values underneath. And for this, we do have to make a few changes to our eval script as well as our request. So for instance, we always need to return a data mask. You can see this here. Our outputs are actually explicitly defined. We have a NDVI output as well as a data mask output. So that's a compulsory part of a statistical API request. And actually our default sample type, so as I'm sure you know, rasters have different sample type formats. The default for process is uint8, whereas actually for stat API it's float32. And this makes sense because actually statistics, generally you're deriving spectral indices and their values will be generally -1 to 1, and you need the density of values to include decimals, which are included in the float32 sample type. So in this example, we're going to plot NDVI for a single field, and then in the second example, I'll show you how you can do it for multiple fields as well. So let's run this cell first for the eval script. You can see here that we're calculating NDVI like previously. There's no visualization this time. It's just the index being calculated. So in addition to that, we also have some fields which I've defined here. I can plot these on a map, which, okay, this object's not working again. We'll see, actually no, we won't see, but we'll see the results of the time series analysis for that. In addition to the eval scripts, we have some additional parameters to include in our request. We have a time interval. This is the time range of our request. In the example I've put here, we're going from the 1st of April to the 30th of August 2022. And then we have an aggregation interval. This defines the length of time each interval is. So if you wanted to visualize it in your head, you can think of our time range as a loaf of bread, and the aggregation intervals, they're like slices of bread, basically. And here we've defined it as the time interval of 10 days using P10D here. We've also included a maximum cloud coverage filter as well. This means that we're actually filtering out any image acquisitions that had a cloud cover percentage of over 10%. Cloudy pixels are not good for our time series. It creates a very noisy response, and it's not particularly useful to analyze. So having the option to filter those out is really useful for our users. So I will run this cell and we'll see what we get back. And so this takes a little bit more time just because we're going through a whole season of data here. But what we're going to return back is the raw JSON format, and we'll see what that looks like. Okay, give me 1 sec. I'm just going to restart my kernel. Okay, sorry about that. It just took a little bit longer than normal. So here we have what is returned back. It's not particularly readable for a human to look at, but it's extremely machine readable, which is important for scalability. So we can see here, maybe in the first results, we can see that we have a time interval from the 21st of April to the 1st of May. We can see our maximum NDVI value, our mean for our field. And you can see this is repeated for each of our time slices we defined. But it's not particularly useful at this point. However, I've defined some example functions here. And we can very quickly convert our JSON file to a pandas data frame here, which we can then use to create a plot in Matplotlib really quickly. So here we go. Here's our time series of our individual field. I'm just going to go back slightly. So I talked about this other argument we had, which we were eliminating cloudy acquisitions. I'm actually just going to quickly remove it, rerun our result, and we're going to see what the impact of this actually is. So I'll just give this a second to load. Scroll down and we can see here that actually we have a little bit of a noisier response. I'll just reinsert that back in and rerun those cells. But what's probably more powerful is that actually you can start to compare different fields. So let's run the next couple of cells where I'm actually going to compare two fields together. So you can see here we're just running the same request again, but on a different field. And we can then plot this in one single Matplotlib graph. I'll just give us a little bit of time. There we go. So it's not too long to do. And you can see here actually that we have probably quite differing land cover types that they have. Although they have a very similar NDVI profile from the start of the growing season to mid-June, you can see here that the second field, its NDVI value stays high throughout the season, whereas the first field dipped quite radically in about a month. So probably maybe a mowing event or some kind of harvest. But this is where the value of being able to derive these statistics is significant, as you can start to compare and contrast different areas of interest. So I'm going to return back to the presentation. And now I'm going to give you a quick overview of how you can scale up your workflows. So as I mentioned earlier, we offer the batch processing and batch statistical APIs. And this enables you to kind of upscale your workflows to either national or even continental scales. So as I said, yeah, you can request data at large scale. So it could be spatially. So you could, if you wanted to, you could create maybe a cloudless mosaic of the whole continent. Actually, these have been generated for Europe. If you're familiar with the Copernicus data space ecosystem, you can actually access the quarterly Sentinel-2 cloudless mosaics, which have been generated using the Sentinel Hub batch processing API technologies. You can also run on large temporal scales as well as spatial. So you could create cloudless mosaics for as long a time period as you wish. And using the batch processing APIs, you can actually monitor this very easily and also generate this kind of data very cheaply compared to previous, more localized methods. So on the right here, we're looking at a cloudless mosaic of Slovenia. This took, I think it was about 15 minutes to generate. So you're looking here at a national cloudless mosaic using a year of Sentinel-2 data. The data crunched in a very, very short amount of time. And another example of batch processing is here we have NDVI maps of the globe, and you can see how NDVI changes spatially but also temporally over, I think this is from the year of 2016 or 2017. It's really cool seeing how the seasons are changing from hemisphere to hemisphere, for instance. So as well as the batch processing API, we have the batch statistical. This enables you to monitor thousands of fields at the same time in single requests. And applications for this include the Common Agricultural Policy, which enables government agencies and farmers to actually access thousands of fields at the same time, which can be used to derive yield data, but also to police whether the farmers are actually reporting the correct crop types to the relevant authorities, for instance. So this is already being used in the real world for good. And lastly, I just wanted to touch on EOLearn, which is another dedicated Python library offered through Sentinel Hub. This is actually free and open source, but obviously it's tailored for use with the Sentinel Hub APIs. And what this library does is it acts as a bridge between the data science ecosystems and EO data. So there's lots of really cool functionality within this library that enables you to easily pre-process satellite imagery for machine learning applications. So if your project involves machine learning and you're using Sentinel Hub, I'd really recommend checking out this library to make your life really, really easy. Okay, so I'll quickly summarize before we go into some Q&A. So yeah, today I've just quickly reintroduced the purpose and goals of our APIs, as well as reintroduced the API's features and functionalities, and then also demoed the APIs in Request Builder and the Jupyter Notebook, showing you how you can search, discover, and visualize the data, but also start to run some analytics using the Stat API. So yeah, I don't have too much else to say. So I'll pass it over for some questions and answers. And of course, lastly, I have a slide just with some useful links. I'll try and make sure this PowerPoint is shared afterwards so that you can access them. So I'll pass back to Federico.
Thank you, William. Thank you very much for this presentation. And I think that the links are really, let's say, welcomed from our attendees, because they were asking if it was possible to have the Python, the Jupyter Notebook file.
Yeah, that's actually available on GitHub.
I don't know if you can. Okay, perfect. I don't know if you can share the link at the moment on the chat so they have it. And then we have a question which is related to working on QGIS instead of ArcGIS. And the question, I think, it's is if there is the need only to change the line command, the command on the line to work on QGIS, I think. But if I didn't get the question correctly, please, Rinalda, write it again.
Yes, please. Yeah, I didn't quite understand the difference you mean between QGIS and Arc.
Yeah, so please, if you can write the question again. And we have another question in the meantime, that is, what are the similarities and differences between Sentinel Hub and CDSE, and when would you use one or the other?
Okay, yeah, that's a really good question. I think it's from David. So there are differences, but there are also a lot of similarities. So Sentinel Hub is actually deployed in 2 different places. So today I've been talking about Sentinel Hub deployed in its native environment, where you can access obviously all the Sentinel missions still, but as well as that, things like Landsat and the third-party data as well. But however, there's also a deployment of Sentinel Hub on the Copernicus data space ecosystem. This has slightly different data offerings. You still have access to the Sentinel missions, but currently you don't have access to Landsat. So that is kind of the main differentiating factor that there is currently. However, there's a big difference in that on the Copernicus database ecosystem, Sentinel Hub is actually free to access under some fair use limitations, so you can still process large amounts of data. I think you have enough quota per month to calculate, for instance, a mean NDVI mosaic for the whole of Austria, for instance, which is quite a large amount of processing units to have. So to go back to the question, when I would use one or the other, if I was using solely Sentinel-2 data or any Sentinel mission data, and I wasn't using huge amounts of processing units, then I would probably stick to the Copernicus database ecosystem. But if I wanted to use Landsat data or some commercial data as well, then I would probably be using the Sentinel Hub or the more native Sentinel Hub. But that decision will change from person to person and use case to use case. It's probably not the easiest question to answer.
Thank you, William. Another question is, can I carry out analysis and processing with the Sentinel Hub QGIS plugin, or is it just for data download?
The QGIS plugin is more for visualizing the data and streaming it in. So the analysis is obviously occurring in the eval script itself, but I guess the purpose of the QGIS plugin is more to visualize the data And maybe if you wanted to add some vector layers on top, it's much easier to do that in QGIS. So think of the QGIS plugin as almost like EA Browser, but in QGIS.
Thank you. Then we have a question from an attendee who is new to Python language. So the question is there any notebook in Jupyter to estimate glacier surface velocity?
Not as far as I know. Yeah, one limitation that we're still working on with Sentinel Hub is that our eval scripts work on a pixel by pixel basis. I think to start analyzing glacier surface velocity, where I think you're probably tracking features on the ground that move, that would probably not be currently possible in just the Sentinel Hub APIs. You'd have to probably download the individual images and then work on some feature detection offline that way. But as far as I know, I don't know any examples of that or any Jupyter notebooks that offer that example. So maybe that's something for you to work on for yourself.
Thank you. I take this occasion also to remind all the attendees that there will be other 2 sessions of the NOR webinar series, and the next one that will be in 2 weeks. So next week we will not have a session on the NOR webinar series. It will be in 2 weeks, the next one, and it will be on Polar thematic exploitation platform. So in that case, maybe there will be more information related to Glacier and everything related to the Polar community, if you want to attend. Okay, I don't think we have any other questions for now, so I will, of course, if you have any other question, please feel free to write them in the chat. In the meantime, I will share my screen if it works and if the connection doesn't crash, let's see. And I will try to show you the NOR portal. Okay, so if you want to access the network of resources, services, and different resources available to the NOR, you need first of all to go to the nor-discover.org webpage, which is the network of resources portal, and you will find some useful information about this ESA initiative, as I was saying at the beginning. So on the, let's say, web page, you have already some useful information. For instance, the number of approved projects, the number of providers onboarded, and of service offered through the network of resources. You can have also other information by going to the news section, where you have the latest news about the network of resources, new providers, and so on. You can go to the outreach page. I also wrote this on the chat before. This is the page where this session and all the other sessions of the Network of Resources webinar series are available after the session happens. So, for instance, also this one will be available here, and you will have a link to a YouTube video. Then to access the service themselves, you need to go to the portfolio page and clicking access it here. That will redirect you to the Network of Resources portfolio, where you have all the different services available through the NOR. You can search for what you're looking for with the text search. You can filter with different filtering types. And you can also scroll down here the list to find what you're looking for. Let's say we want to look in this case for Sentinel Hub. So we find Sentinel Hub here, and we have some details about this provider and services. We have a collections overview, the different collections available through this provider, and we have also a provider help desk link. This is really important because you always want to check first with the provider if the services you want to ask to the network of resources for your project are really helpful for it. Then once you have found, let's say, what you're looking for, you can go to the pricing wizard to have an overview of the cost and of the different services. So the first thing that you need to do is to identify the project type you're working on. We have 4 different project types: commercial, research, pre-commercial, and educational projects. And only research, pre-commercial, and educational are eligible for ESA sponsorship. Let's say we are working on a research project, and here we have a list of the different services available through the NOR. So we want to select one service, we click on the tick box, we can change here the number of units and the duration in months. Let's say we want to ask for a 6-month license in this case, and we will have an update of the cost. Then by scrolling down, you will have an overview of the cost here and 2 different options. The first one is to go directly to the provider website and ask the provider for the services, or you can ask ESA for sponsorship. In this case, you need to select if you're working or not on an ESA project. Let's say we are not working on an ESA project, and if you will or not co-found the cost. Let's say we are not co-founding the cost. Then we click on Ask ESA for sponsorship. We want to remind you that there are some eligibility criteria, like, as I already said, the project type, but also the requested amount that should not be more than 5,000 euros. And then once you are on this web page, you will find the form itself that you need to fill out, starting with the project title, the name of the project coordinator, so your name in this case, the project coordinator work category, the official email address. Really important, it must be the organization email address. We cannot accept personal email addresses like Gmail or any other personal email address. The project organization name, country, web page, and address. Then you need to let's say, fill out all the parts related to the project itself, like the project objective, the implementation methodology that you are going to use to reach these objectives, the expected results, and then, really important, the justification for selected services and provider. This is why we always advise you to contact first the provider help desk, because here we want to see why you decided to ask for specific services, and also the work that you're going to do within the cloud environment. As I already said, the network of resources is an ESA initiative aiming to bring user to data and not the contrary. So we want to see that you're going to work within the cloud environment. Then you need to select the geographical area of interest of the project, like if you're working on a specific city or cities, regions, and so on. And if it is the first time that you have applied for NOR. If it's not the first time, you need to write here the ID of the previous sponsoring request. Then you will have an overview of the resources that you are requesting, and the last things that you need to do, the expected date of submission of the set of slides in the way of month and year. What is the set of slides? Is a PowerPoint or PowerPoint-like set of 4 to 5 slides where you clearly state why and how the resources you requested through the network of resources were helpful for your project. If you didn't succeed, let's say you didn't reach your final goal, we still want to see how you use the resources. And I want to remind you that this is a mandatory document. So at the end of the project, you need to send the set of slides. Then you can or cannot sign up for the NOR newsletter, but you must accept the ESA privacy policy. Once you have done all of this, you need to export the sponsoring request. It will create a PDF file. You need to sign the PDF file, and if you are working on an ESA project, you need to have it also signed by the ESA technical officer. Then you need to email it to nor-sponsorship-request@esa.int. Once you've done this, the request will be analyzed, and this process can take around 6 working days, but it might take also longer if we need more information. But in that case, you will contact them. So that's on this part. I saw that in the meantime, some other questions were asked in the chat. So I don't know if you, William, replied to all of them. Maybe yes, let's see. So I'm using offset tracking surface velocity. Can you please share more detailed? Did you reply to this one, William? Sorry to...
No, it's a bit more of a difficult one to answer. I think the simple answer I can give today is just that Sentinel Hub only offers Sentinel-1 GRD data. So we don't offer SLC, just for a variety of technical reasons, but also the complexities of actually processing SLC data. It doesn't make sense for us currently to offer it on Sentinel Hub.
Okay, thank you very much. I see that you have already answered to Sarah. I just going to read the questions. So for the recording, if everyone want to go back to the video. I was using Sentinel free trial and my month trial was finished. So can I register using different email register with no sponsorship? Of course, the answer is you can still use your original email. But you need to go, of course, to the sponsorship request. So in that case, you need to follow the procedure that I showed you, and then we will evaluate your sponsorship request. So, okay, I think that if there are no other questions, I will thank you again, William, for your presentation, and all the attendees for the questions and your participation. And I remind you again that the next webinar session will be in 2 weeks. And when this session will end, you will be redirected to a feedback form that we kindly ask you to fill out so we can understand how the webinar series is going and how we can improve. Thank you again, William. Have a nice day, and have a nice day to all the attendees.